Welcome to today's lesson. This is our physics lesson and our topic today is the turning effect of a force. To start with, I'm going to highlight some few objectives as a learner you are supposed to achieve by the end of this topic. And some of the objectives are: objective number 1, you should be able to define what is the moment of a force and state the SI units of moment of a force. Objective number 2, you should be able to state and verify the principle of moments. And lastly, you should be able to solve the numerical problems involving the principle of moments and the moments of a force. Well, to start with, as per the objectives, we are going to know what is the definition of the moment of a force. And moment of a force is defined as a product of force and the perpendicular distance between the point of support and the line of action of the force. So, from the definition of moment of a force, what is the line of action of the force and what is the point of support? So to explain further, we are going to use the diagram that we have here. In this diagram, you can be able to see we have the point of support here, and we also have the force that is acting downwards, and therefore this one gives us the line of action of the force. And at this point, we have the point of support. The point of our support, in other words, is the pivot or is the fulcrum. And therefore, from the moment of a force, we come up with the formula of calculating what is the moment of a force. So the moment of a force is calculated as force multiplied by the perpendicular distance. And this distance should be in meters. And force should be in newtons, because force, the SI unit of force is the newton. So the force should be in newtons. And the perpendicular distance between the point of support and the line of action should be in meters. So therefore, from the formula here, we are going to get what are the SI units of the moment of a force. And the SI units of the moment of a force is the Newton meter. And this Newton meter is coming right from this formula here. Force is in newtons and distance is in meters. And the product of the two gives us the SI units of the moment of a force, and that one is the Newton meter. Example: suppose you have been given a numerical problem to solve on the moment of a force. Like now, we have this example here. Find the moment of a force about the pivot or in the figure below. The pivot, remember, is the point of support, or is the fulcrum, or is the turning point. It depends on how the question is framed or what you have been given. So we have our pivot here, that is the point of support O, and the distance from the point of support to the line of action of the force is 40 centimeters as per the given diagram. Remember, we have said that the distance is supposed to be expressed in meters, and what we have been given here is 40 centimeters, and that one means that we should be able to express the 40 centimeters in meters. So from measurement, we know that 1 meter is equivalent to 100 centimeters. Therefore, the 40 centimeters, when expressed to meters, they are going to be equivalent to 0.4 meters, and therefore the moment of a force is going to be given as force multiplied by the perpendicular distance, and the perpendicular distance is 0.4 meters now, and the force we have been given to be 20 newtons, and therefore we have 20 newtons multiplied by 0.4 meters, which gives us 8 Newton meters.